Hello everyone, today I'm going to discuss about fluid mechanics, fans and blowers. So a fan draws 1.42 meter cube per second of air at a static pressure of 2.54 cm. So we have this one, 2.54 cm of water through a duct with a diameter of 300 mm. We have that one. And discharges it through a duct of 275 millimeters. We have that one. And we have this one. So 28 degrees Celsius, so we have that one, and 760 mmHg, which is 101.325 kPa. Okay, so here the air power, or let's say P air, the HP required to drive the fan. Okay, so P, then we have the specific let's say density air, and Q, and head total. Okay, so here we have this one is just equal to density times gravity. Okay, so since we don't have the density but we have the temperature, we could just use the PV MRT. But we know that mass over volume is just density, so we can simplify it to this one. So since we have this one, we could get this one, then this one. Okay, and then we have the Q, so it's all right, and the head total, so we'll tackle that later. So first we need to get the density. So we have pressure of 101.325 kilonewton per meter squared. About that. So we have 0.287 kilojoules per kilogram Kelvin, and 28 plus 273.15. We have Kelvin. So cancel, and we know that the kilojoules here, the kilojoules here is just kilonewton per meter. So cancel kilonewton. Then the meter squared will go to the bottom. So we have meter cube. And then the kilogram here will go to the top. So our final unit is kilogram per meter cube. Okay. So we have 101.325 and 0.287 times 28 plus 273.3. We have 1.17 kilojoules kilogram 17.2 kilogram per meter cube. So we have now density and gravity, which is 9.81, and Q and HT. So we know that HT is just equal to HS plus HV. Okay, so we have HS is equals to head of water multiplied to density of water, then the density of air. So the head of water is just this one, 2.54 cm H2O, because if the water is, let's say, experiences this type of pressure, they would have a head of 2.54 cm. Okay, so 2.54 is just 0.025412 meter. Okay, then we have density of water, which is 1000 kilogram per meter cube, and then we would have the density of air, which is 1.172 kilogram per meter cube. We have HS 0.0254 times 1000 times 1.172, 21.672. meters. So HV is just V squared minus V squared, I mean V squared, then 2G. So here we first need to say solve for the velocity. So we know that Q is equals to AV. So therefore, velocity is equals to Q over area. So the Q is 1.42. Then the area is pi over 4. Since this is a circle, so pi over 4 we have 100 mm, or say 0.3 meters and 0.275 meters. 0.3 squared is equals to this V1. So 1.42 and pi over 4. Sorry, pi over 4, 0.3 squared. So we have 20.09 in meters per second. Okay, we have this one. And just change this one to 0.275. So you would have 23.91 meters per second. But yeah, we just subtract this 23.91 squared minus 20.09 squared, then 2 times 9.81 meters per second squared. So we would have 2.91 minus 80.09 2 times 9.2, 8.57 meters. So we just need to add this one, then we have the H total of 21.672 plus 8.57. We have 30.242 meters. Okay, and now we solve for the power air. So we have density, gravity, Q, HT. Okay, so density of air we have, I forgot, 1.172 let's say kilograms per meter cube. And then gravity, which is 9.81 meters per second squared. And then Q, which is 1.42 meter cube per second. And then the H, which is 30.242 meters. So let's cancel this out properly. So we should have watts. Okay, so 1.172 times 9.21 times 1.42 times 30.242. We have 493.767. I mean 737 watts. So watts is just, say, joules per second, or joules per second, same. So joules per second is just Newton meter per second. So we have kilograms here and meters per second here, so it would result to Newton. Check. Then we have meter cube here, cancel out, and then we have meter left. So we have meter here per second, which is a second here. So Newton meter per second, or joules per second, or just watts. Since we need it to be, say, HP, we just need to convert it. So we have 493.737 watts is just 746, if I'm not mistaken. 746 watts is equals to 1 HP. So divided by 746, you have 0.66 HP. Okay. So I hope you have learned. Oh no. Still have a second question. So sorry. If the static fan efficiency given the total mechanical efficiency is 65%. So we know here in B, sorry. So we know in B the mechanical efficiency is 65%. We need to find the static efficiency. So static efficiency is just the efficiency without the efficiency with respect to the static head. Okay, we have static efficiency over mechanical efficiency is equals to static head and head total. Okay, we have ns 65% or 0.65, just 0.65. Then hs, which is 21, yeah, 21.672 meters, and 30.242 ht, 30.242 meters. So we have ns of 21.672, 30.242 multiplied by 0.65. So we would have 46.58% efficiency. So I hope you have learned something, and see you next time. Bye bye.